Hello students, welcome back to yet another lecture on statistic. In my last lecture, I explained to you all guys measure of dispersion for the mean deviation. In my today's video, I'm gonna explain to you all for the standard deviation. Okay, measure of dispersion for the standard deviation. Okay, so let's get started with the standard deviation. Okay, already you all are the familiar with the standard deviation and you all have learned this concept in your 12th standard also. Okay, I'm going to relate this concept. I'll explain to you all the formula and we go for some of the examples. So let's get dive into our today's lecture. Okay, so standard deviation. Okay, now standard deviation, we know that it can be represented by sigma. Okay, like this sigma, you all have seen this standard deviation as a sigma. Okay, sigma we denote using sigma as a standard deviation. Okay, but what actually the meaning of standard deviation? Actually, standard deviation measure the absolute dispersion of a distribution. So absolute scatteredness, whenever we have absolute scatteredness, then we apply standard deviation, okay, to measure absolute dispersion. Okay, standard deviation is a positive square root of the average of the square deviations taken from the arithmetic mean. Okay, and we write standard deviation as, okay, standard deviation as under square root summation of xi minus x bar bracket square, summation of xi minus x bar bracket square divided by n. Okay, so this is the formula we use for finding the standard deviation. Or okay, now you know the xi means all the x1 x2 xn, these n numbers are given. Okay, these are the xi. Okay, xi we denote x1 x2 x3 xn. Okay, yes, and x bar means it is arithmetic mean, that means summation of all xi divided by n. Okay, this one is x bar, and n means number of data. Okay, number of observations given, it is denoted by n over here. Okay, yes, so this is a standard deviation. Or we can write this standard deviation as, okay, so we can write this standard deviation as or under square root summation of xi. Okay, summation xi bracket square, summation of xi square divided by n minus x bar bracket square. Okay, yes, so we can write this one also, we can write this one also standard deviation, or this one also. Both are the standard deviation, guys, don't get confused. You can apply this result form or you can apply this form also. Okay, it's not the difficult. Now see that this is only for the ungrouped data. Okay, this is only for the ungrouped data. Similarly, we have to introduce fi for the grouped data. Okay, yes, this one is only for the ungrouped data. So if you have given a random x1 x2 x3 xn, then you have to apply this formula for finding the standard deviation. Okay, yes, let me write this one is for ungrouped data, for ungrouped data. Okay, and for grouped data. Okay, for group data I'm going to write it here for the group data. Now see that in group data we have frequencies. Okay, we have frequencies given, so instead of that n we will get the frequency, and instead of that bracket we get the frequency into this bracket. Okay, let me write for group data standard deviation. Okay, standard deviation for the grouped data. Okay, under square root, okay, under square root we write summation of fi, it is the frequency fi, okay, into xi minus x bar bracket square. This bracket it remain as it is, it won't change. Okay, yes, so xi minus x bar bracket square. Okay, total divided by, instead of n we are taking capital N. Okay, or instead of capital N you can write summation of all frequencies. Okay, so this one is the formula that we apply for finding the standard deviation for grouped data set. Okay, whenever we have grouped data sets given. Okay, yes, so this one also you can use, or maybe there is one more form for finding the standard deviation that you can apply it. Okay, yes, so under square root we write, okay, under square root we write summation of fi xi bracket square. Okay, fi into xi bracket, this is the square for only xi guys. Okay, and divided by summation of fi and summation of fi minus x bar square. Okay, minus x bar square. So you all need to understand this terminology. Fi is the frequency, xi means we have given observation x1, x2, xn. This one we call it as the xi. Okay, yes, these are the xi. X bar means arithmetic mean given, summation of a frequency. Okay, that means all frequency whatever we have, we consider summation of frequency here, add all of them here. Okay, and similarly all these notations same here. Okay, for the standard deviation, that is here guys, for the standard deviation of grouped ungrouped data set and grouped data set. Okay, it's not that difficult for finding the group data set and ungrouped data set. I'm gonna add some of the result here for coefficient of variation and the square of a standard deviation, like we can call the square of standard deviation as a variance. Okay, so let me write two results, they are important here. So these are the important remark here. Okay, so we already familiar with the square of a standard deviation called the variance. Okay, so we know that variance as a sigma square. Okay, we write variance as a sigma square. Okay, this one is the part from 12 standard. Okay, variance as a sigma square, that means square of a standard deviation, sigma denoted by standard deviation, and whenever we take the square of standard deviation we get the variance. Okay, this remark says that, this condition says that. Okay, yes, now one more, coefficient of variation. I found a question based on the coefficient of variation in your question paper. Okay, you will get the raw data set in your question paper, and they will ask you for finding the coefficient of variation. Okay, so coefficient of variation means you have to find out the first of all standard deviation means sigma. Okay, now you have to figure it out whether that standard deviation applicable for the group data or ungrouped data. Okay, then they have to figure it out, standard deviation first, and then find out the arithmetic mean for that standard deviation. Okay, given data set and multiplied by 100, so you will get the coefficient of variation using this result. Okay, yes, so for why we are finding the coefficient of variation and how you can identify in your question paper that we have to apply coefficient of variation. Okay, yes, now first condition is here for comparing variability. Okay, for comparing variability of a two series. So you will get the two different series or data sets. Okay, and you have to compare that variability. Okay, so using this one you can understand whether we have to apply coefficient of variation or not. Okay, and next point, after finding the coefficient of variation, if the value for that coefficient of variation is a smaller, okay, lesser value, whenever it is a smaller value, then we consider that coefficient of variation is a more consistent. Okay, but if the coefficient of variation having larger value, if a coefficient of variation having larger value, then we consider it as the less consistent. Okay, so need to understand, or you don't need to remember both of the points, just need to remember one. If the coefficient of variation gives us the lesser value, then we say that the our data set are more consistent. Okay, yes, that is here for our standard deviation guys. I hope you all have understood standard deviation for standard deviation for group data and ungrouped data in my today's session. Okay, so just need to remember these formulas guys, and the coefficient of variation, that one is important. Okay, so that's it for our today's lecture guys. From my tomorrow's lecture onward, we go for solving some of the important question that are helpful for your university question paper. Okay, that's it for our today's lecture. So thank you everyone, thank you for my today's lecture.